Hi everyone, good evening and welcome back. So I was just doing a very quick 5-minute recap. So we're implementing a USB sound card running on the iCEbreaker-bitsy, which is a small FPGA board with an iCE40 FPGA. And this is done by having a USB soft core connected to a RISC-V soft core, and then some logic to do pulse density modulation to just generate audio on 2 GPIO pins, basically. During last stream, we focused mainly on the hardware. So I explained the general architecture of the SoC that's running there that we started with. And then we implemented a special audio peripheral that allows us to actually push audio from the SoC. And we also started on the software, mainly creating the USB descriptor so that the card is actually detected as a standard USB sound card. But except for the USB descriptor, we haven't actually implemented anything. And so that's what we're going to do today, is implement the USB side, which is mainly firmware work. And so if we look at the USB audio specification, so we mainly have two things to implement. The control plane and the data plane. And the data plane is basically getting the data from the isochronous endpoint and feeding that to the USB core we implemented. And the control plane is responding to the control request of the host PC, mainly to set the volume and mute control, because that's the only two control that we declared to support, as well as the actual beginning of streaming and end of streaming commands that we can receive. So we're going to start with the control plane, because we can probably test the control plane without the data plane being implemented, but we definitely can't test the data plane until the control plane works, right? So what control do we need to implement? Well, we actually can kind of a hint if we look at the USB message that are thrown when we currently enumerate, is that we have the cannot get min max values for control, and then USB set interface failed a bunch of times. So set interface is going to be selecting the alternate settings of the streaming interface. Remember, we have two. If we go back to the LS USB output, we have okay, that's our audio streaming interface, and we have the same interface, so same interface number 2. We have two alternate settings, alternate setting 0 and alternate setting 1. One has no endpoint and no data, and that's when the stream is off. That's all the PC signals us that the stream is off. It selects these alternate settings. And we have this alternate setting that tells us when we need to start streaming, and then we have some active endpoints that we're gonna need to shuffle data to and from. So that's the first part of the control, is accepting the set interface for on and off. And the other part is described in the USB specification, in the USB audio class specification. If we look at the index, yeah, those are set and request values. So it's page 66. So there's a few standard requests, both setters and getters. And you have set and get for the current value, the minimum value, the maximum value, the resolution, and memory. If you actually read the text, memory is sort of to do like memory mapped I/O, but it's vendor specific. Like there is a standard way to encapsulate it, but it's for vendor specific control system, and we don't have anything vendor specific, so we don't care about those. We also don't really care about the resolution. We just accept an arbitrary resolution, and we will handle that ourselves. So mainly we concern ourselves with the current value and the min and max for the control we support. And if you actually look at the text here, somewhere, I don't remember where exactly. Yeah, here, in most cases, only the current and mem attribute will be supported for the set request. And that makes sense. Like you can't, most of the time you can't configure the minimum and you can't configure the maximum. They're like fixed by the hardware. And so the only command that we must support are the set current value and then the get current, get minimum value, and get maximum value for the control we support. Okay, so now what value can we actually configure? You have those. So all of those are control requests on the control endpoint. If you're not familiar with USB, it's like a standard way of tunneling control, control requests or control calls that have like a standard attributes, basically, which are described here, which is the type of request, the actual code associated with that request, and then several standard fields, the W value, W index, and then an arbitrary data block of a given length. And that's what they describe here. So those requests, they can be sent either to an interface or to an endpoint. That's what they describe here. Those requests can be sent to a given interface or a given endpoint. In our case, in the descriptor, we actually specify that we don't support request to endpoint because those are used, at least in the USB audio specification, the request to endpoint are used to change things like the pitch or the sample rate. But we have a fixed sample rate of 48 kilohertz, and we don't support any kind of pitch adjustment, which means we don't have to support any kind of request on endpoint. So we only support them on interface. And that's the audio. If you look at the descriptor, we have here, bitsy audio control. That interface is where we're going to receive all our control requests, and that's where we need to handle. And what kind of control request? Well, look at the spec. What kind of control can we have on the terminals? So if you remember, the USB audio descriptor kind of describe a flow graph of information where you have terminal endpoints, which can be input terminal or output terminal, and then kind of processing block. And in our case, we have one input terminal, which is the USB stream. We have one feature block, which is volume and mute control. And then we just have the output block, the output terminal, which is analog, audio, headphone. These are the three entities that we described yesterday in the audio descriptor, and you can actually find them here in the descriptor. We have our that's what describe our input terminal, which is a type USB stream. We have a feature unit, which supports mute control and volume control. And then we have our output terminal, which is headphones. So what kind of requests do we have on terminals? Well, if we look in the spec, terminal controls, the only terminal control which is defined in the specification is copy protect. It's basically you can define if you're streaming copyrighted music to prevent copy protect to handle like copy protection. We absolutely don't care about that, which means we don't need to support this control request at all. So we don't care about that. So the only control requests we're going to need to handle are the ones on the feature units, feature unit control request. Okay, so that's what we're going to need to handle. And so if we look, the two we support are mute control and volume control. So as you can expect, mute control is basically just a single byte per channel that tells, true if it's muted, false if it's unmuted. That's pretty obvious. And for the volume control request, we have 2 byte per settings, which correspond to this, which is the volume setting in decibel, and that's basically a signed 16-bit integer, where you take the value of the 16-bit integer, you divide it by 256, and that's the value in decibel of the volume that you need to set, which means that's logarithmic volume control, right? Something that's described in the text also is that each of those requests can either act on one single channel at a time, so left or right, or the master channel, or it can also act on all channels. And then you see here in the second form, if the channel number that's given in the request is 0xff, then it's a list of settings for all the available volume controls. And we only have 2 volume controls, right? We have 3 channels, the master channel, but that one only supports mute. It doesn't support volume. And then we have 2 channels that support volume control left and right. Okay, so let's start implementing that. We just so does this make sense so far? So I'm gonna create a global structure. Okay, great. I'm gonna start creating a global structure to hold the state of the audio stuff. So actually, so one thing I did prepare before the stream, because I was bored, and I read that the volume control, as I said, is logarithmic, right? But our multiplier is linear, which means we need a function to convert from log to log volume to linear volume, and back again for the read back. And so what I did is I prepared a couple of functions which compute convert the volume into multiplier value using lookup tables, because I don't want to start to have like float math in here. So I will quickly go over those first. So there is 2 lookup tables, one for well, basically exponential, and one for log. And the way it works is that's only the fractional part of the exponent. So this contains the power of 2 between 2 exponent 0 and 2 exponent 1. And this contains all the log2 values between 1 and 2, basically, with a like a precision of 1 divided by 256. And the way those functions work is they handle especially the integer part of the logarithm or of the power, and to bring it into like a sort of a standardized range. And then they do the lookup table, and then they do the final scaling, combining the integer part with the lookup table part to give the final result. It's not super fast, but it's probably faster than doing it in floating point, and it's going to be probably smaller than bringing in all the floating point routines inside the firmware. And so what I have is that lin to volume log to lin is going to convert the int16 value as specified in the USB audio specification into exactly what I need to put in the multiplier to get that volume value. And then you have the inverse function, because according to the USB specification, since you can't set the exact volume, you receive a set volume command. You set it as close as you can, depending on your hardware, resolution and whatever. And then when you do a read back, you read back the actual volume that was set, basically. Yeah, well, here there's actually a precision problem here as well, because the function, like if you do the conversion in one direction and then back again, it's not a fixed point, right? So we're gonna need to handle that by basically caching the value, because you have precision issues here as well. But it's not gonna be. Yeah, it probably would be. So here I'm gonna store value for each 3 channels, even though we don't have. Actually, no, I'm just gonna store for 2 channels. And so I have the mute control, the volume in logarithmic form, which is as given in the USB request, that I'm gonna cache as well, so I can serve it back and kind of fake a fixed point. And then the actual multiplier value for this. And I'm also gonna store the global mute. Yeah, doesn't matter. There's a link for putting the function return time on its own line. Oh, I don't know. I just think it looks better. Especially, I don't like when I scan for function names, I don't have to go in the middle of the line. I mean, here they're all relatively short, right? It's static void and stuff like that. But when you have like a function that returns like a function pointer, or when you return a pointer or an array or some complex type, it's just annoying. And that also allows me to don't not reach like the 100, or you see here I'm more, because I'm using a larger font than usual. Here I'm more limited to like 80 characters per line or something. So yeah. But see, like for main here, I forgot to do it. So like oh really interesting. Yeah, I mean it's just a style question. Like everybody, yeah, sometimes have different opinion. Okay, so I need to. So we're gonna start with all channels muted actually. So yeah, I'm like 10 lines in and I already have using the wrong the wrong names. Thank you. Um, so what I wanted to do is create a function that's just gonna audio hardware because I don't have hardware volume. I want to basically hardware. Dot vol then. Damn it, that doesn't fit on a single line on with this font size, which is annoying. I think that's correct. So basically, the idea is just setting the audio registers with the right value, depending on the mute control. And I'm gonna call this both in the init function and then later on when actually setting the volume. G-audio.mute all. That build. Yeah, it's correct. Okay, so that's mostly for the OS structure, the hardware. So I'm just gonna say local state, hardware, and then we also need to plug into the USB part of the stack. Okay, so I'm gonna look at some example code in the DFU bootloader, for instance. I don't think that's gonna be here. No. Firmware. Yeah, we can look in here, for instance. So the way you plug into the USB stack is you define a structure which is called USB function driver, on which you can set set some callbacks basically, and that's what we're gonna do. We're gonna define our own driver. So I must warn you that this USB stack is is not complete. It's not complete yet. Like I'm still working on it. But I want to basically implement like a bunch of different devices using it, so I can see what would make sense, what wouldn't make sense, and that kind of stuff. So far, the main thing that's missing is there is currently no API to really handle data transfers. So you have to manipulate the USB registers manually. But it's not that hard. But I want to provide a nice API for that. But I haven't come up with one which I fully like yet. So that's still a work in progress. So the three cores we're gonna be interested in here is the control request. So if we get some control request for the USB audio interface, we need to handle them. And then we have the set interface and get interface, which are the possible alternate settings for the interface that we handle, basically. So let's implement stub functions for those three. So I'm just gonna copy the function arguments, control request, Actually, given my naming scheme, it would make more sense to call it audio USB, but since I prefixed all the function with audio. Okay, so the control request, for the moment, we're gonna say that we don't handle it. So these function, most of the time, they can take 3 return value, which is a continue, and success and error. So continue means it's a request that's not for you. You don't want to handle it, and you defer to some other driver or to the stack to answer for you, basically. Error, it means, okay, that was a request for you, but it terminated in error. And success, meaning it was a request for you and you've handled it successfully, basically. Here we're just saying we don't handle this request. It's just a stub for now. We're gonna handle the set interface and get interface. So, but we only want to handle some of them. So we only want to handle interface if it's of the audio class. So we're gonna check the audio class and see if that's it. I don't remember it by heart, so I'm gonna recheck the descriptors to know what the that's the DFU one. So if the interface class is not 0, 1, then it's not for us. Same thing for the set interface. We're gonna need to save which alternate settings we have currently selected. Actually, we just have a bool because we only have the active and the inactive interface, right? But we have 2 interfaces. We have the audio control and the audio streaming one. The audio control one only has 1 alternate setting, which means that we need to handle that separately. It's switch, it's not case, it's not Verilog. yeah, so I keep keep confusing with Verilog. I had a dot there, thank you. And there we have case. And we handle audio control and where's the other one? Audio streaming. I don't remember. How do we return the value on this? Okay. So if it's audio, if we have a set interface on the audio control, we don't actually need to check anything because the USB stack will check for you that the selected alternate setting actually exists. And so since we only have one, we know it's going to exist, right? So we don't have anything to check. And here we just need to set G. Well, okay, I'm just gonna say fix me because I mean we need to store the fact if we're active or not, right? But we will have more stuff to do at some point. Currently, we don't have anything else to do than this. So, but at some point, if we're transitioning from off to on, we have to start stuff, and we're transitioning from on to off, we have to stop stuff. At the moment, I'm just gonna stop. I'm just gonna store the settings so that the set get thing work, but it's gonna need some fixing. Actually, so does this build? No, because I need to. I mean, it doesn't matter that they're gonna be the same, but okay. So we can actually try this. This should get rid of this, of the USB set interface failed. Sorry. But I mean, the two are pretty independent because during the first stream we implemented the hardware side, and we implemented the USB descriptors, which is all the structures that describe the actual sound card here, but none of the actual like software logic and USB logic and USB stuff. And that's what we're doing this stream. So you can just assume that in the past that now we have a SoC which has a peripheral that allows the RISC-V to play audio, but now we actually need to feed it audio. That's basically it. And so yeah, what I was saying is during the last stream when we just implemented the descriptor, and when we plugged the device, it enumerated correctly, but then we pretend to be a sound card, but we don't implement any sound card stuff, and so the kernel was complaining about a bunch of stuff. Here we just implemented the set interface thing, so that should work, except of course that I just implemented some function. I actually need to tell the stack that I want to enable this driver, and so we need to do USB register function driver. Let's see how that works out. Okay. Huh. Well, I was wrong. That's what happens when, well, you don't prepare, right? But that's kind of the point, is to discover what the hell is going on. um, I mean, one thing we can try to look up is what. Let me see if I have. I want to see if I have Wireshark and a USB mon to see the control request. So I just installed Wireshark in the background. Unfortunately, I won't be able to capture anything because I'm not super user and I'm not in the Wireshark group. And if I add myself to the Wireshark group, it's not gonna work until I reload. Until I. Oh, okay. I need to find a way to. E-pipe. Yeah, that's not helping that much to. I'm currently trying to think. Oh, I'm gonna get links from the chat to here because I have the chat open on my laptop and not on the streaming machine. Wait. Oh wait, no, I have it open somewhere. Okay, I can do this. No. Ah, no. Okay, I need to open it here because I have the chat open, but in everything you're seeing streamed is basically a nested X server inside my main machine. Oh, and of course I don't have chat history. Can somebody repaste the link? Elixir.bootlin.com. Okay, I can try that. Oh yeah, okay. Yeah, that's gonna be enough. Driver USB core. Okay, driver. USB core message. Let's see. 1439. Okay, so it is when selecting alternate setting that something goes wrong, right? So you know what? Okay, so we don't actually get cold at all. That's interesting. Oh, you know what? I call audio init, which registered a function driver. I called that before I initialize USB. So the USB initialization will clear the driver list and not be registered. Ah, look at that. We have our set interface and we don't have the error message anymore. Okay, I'm not crazy. So what's actually interesting is that it enables, then disables, then like by default, the audio is enabled. Like it's streaming, it's trying to stream audio right now. I'm not sure why, but okay. It's probably Pulse Audio probably opens the stream by default or something. Yeah. I actually wonder if, does it show up in Pulse Audio now? Yes, it does. Okay, I thought I screwed up something. Okay. We now have a card. iCEbreaker-bitsy, bunch of stuff. It's kind of weird that it thinks it has a digital stereo output, but okay. Yeah, I have a FPGA. I have this, yeah. And so we do see R2 audio channels. Okay, great. So now we need to implement the other part, which are the actual control requests, right? To set and get the various values. What do you mean the audio input side? It only listed the output. Yeah, it's just it only has outputs. Yeah, what I declared in the descriptor is the input terminal, is because you need the input terminal that I described is it's not a physical one. It's like it's the USB. It's a USB stream. That's all the data flow model. You kind of describe a bit of a JStreamer graph basically, or something similar inside the descriptor, with one of the input terminal being the isochronous endpoint, and the output being the actual physical analog output. Okay, so the controls. If I take back the specification, so control selector, blah blah blah. Okay, so the values are defined in section 810. Okay, so let's go to that. Yeah, okay, yes. Okay. These are not values that I already defined, so I need to just outstanding. I would have loved to have the yeah, I don't know why he didn't paste the line returns. That would have been good. Okay, I'm gonna call that USB audio class feeder unit controls. Okay, it's good enough for now. So so the first thing we're gonna check is if that control request is for us at all. And let me check my okay, here apparently I didn't check the interface. I just checked the index of the interface. I can do that too. I don't know if I have an easy access to. No, I don't actually. I know I don't. Oh, but wait, actually I need to check because they kind of mix stuff up. So what are the fields that are filled for these control requests? So it was page 66 or something, 68. Okay. So I need to check W index, and I need to the field will contain both the interface and the value in the area must be appropriate. Only existing entities. So I'm assuming they must. Yeah. Okay. W index specifies the interface or endpoint to be addressed in the low byte and the entity ID in the I byte. Okay. Yeah. So what I'm gonna do is check. Check it's a request for the interface. Okay, that's a request towards an interface, and that I'm the recipient on the control interface. So yeah, I can do that basically. If it's not, then it's not for us. It might be for somebody else. We don't care at this point. And then we check that it's actually for this interface, and I can know that by taking rec w index okay, it's not very clean, but for the sake of going quickly, I'm just gonna hardcode the interface number here. Something that I try to clean up later, but I'm actually wondering, okay, if I do this. Let's see what kind of request we get. Requests w index and request w value. Where was I? Oh no, I'm gonna print that as well. Request and type. I'm just curious to see if we're gonna see that request. To check that our filter here is correct and does indeed let stuff through. And it doesn't, so we screwed up something. Oh wait, no, never mind, it did. 81A1. Did we see those before? No. So those are definitely required because 81A1, if I look at, let me actually open the Course no to USB firmware include. So the request 81 and 81A1 more specifically is this. It's a get cure. So that's definitely a request for us. And our filter filtered that out. Why? Request class and request recipient interface. To view index. So is it not a class request and recipient interface? So recipient interface is 1. Okay, so that's correct. And class is 1 shifted by 1. Oh, no, it's not. It's a standard request. One. Wait, no, 1 0. No, it's a class request. Shifted by 1, 2, 3, 4, 5. So that should have gone through. Okay, yeah, that did go through. So, oh. Okay. That was the mistake. So mystery solved. So we do see our request, right? So now I can do switch. This. And so the one we want to handle are basically set current value, the get current value, the get min, and the get max. If it's a different request, it was a request for us. We don't handle it, so we return an error. So, yeah, and if it's not, we handled it. Mhm. So to handle the response to, I mean, for a set request, we don't send data back, but for a get request, we need to send some data back. And you can configure the transfer and say the length of the transfer and a data buffer. By default, the stack will pre-initialize the data buffer to a 64-byte buffer, which is the max length of one single packet, so that you don't have to handle a buffer if your response is small enough. If you want to do a larger response, like in the case here of the DFU, I have uh, kind of large packets. Then I set up a special buffer, but here that's a small request, and I can just directly address the data and set up the transfer. And so that's what I'm gonna do here. Um, Actually, okay, check. We only have one unit ID, right? So if it's not for the feature unit, we don't accept it, and we can actually return an error because it's something that we should be able to handle, but we don't have anything to handle. Not that if error doesn't mean that it's gonna throw an error in the kernel or anything like that, because it's for some control requests, it's perfectly valid to respond with a stall. That's just how it's specified, and that's the case for USB audio. Is if you receive a request that you don't support, you just respond with an error code, I mean with a stall, and the host will know that it's not supported. All controls are optional in USB audio. But of course, because we want, we declared in the descriptor that we have support for mute and audio, we need to implement those, but all the rest we don't care about. Okay, so where's the channel? Selector, feature unit, okay. So feature unit has the channel number and control setting, and so the CS is in the high byte and the CN is in the low byte. Okay. So what I'm gonna do is something like this. That's setting the global, which we handle differently. This sets channel 1 and channel 2. Wait, no, that's not correct. That's not at all. It's for the feature number. It's for the feature that I need to do that, not. I'm just trying to think. Oh, I'm gonna organize the code so that it's readable, but not also not. I think I'm just gonna create different functions for the different. Yeah, I think that's gonna be the. Because here I have a switch for the request type, but then I need a second switch for the different function, and then for the different channel, but if it's the master or the slave and stuff like that, it needs different. So yeah, I'm gonna create different functions and dispatch. I'm not gonna give the request. I will actually pre. Uh, no, you know what? No, I'm just gonna give it as this because I want to test. I somehow suspect that the get min max is gonna be very similar. So let's implement the get min max first. One thing I'm wondering is if, because there is a special case arises when channel number is set to accept, then a single gate feature can be used to retrieve the settings of all available controls of a certain type. I'm wondering if it's mandatory to support that or not. If I have to bother, yeah. Okay, so the two functions that we support get min max for well, that's only volume, right? Exact text of what? Oh, here. A special case arises when the channel number is set to 0xFF. Then a single get feature unit control request can be used to retrieve the settings of an attribute of all available controls of a certain type. There is no show, shoot, can, or anything like that. Yeah, that's. And these are the min-max values. So the maximum volume we support is 5 dB basically. It's slightly under 6, so I'm just gonna call it 5. And it's in 256 of a dB, so it's gonna be 1280. Okay, X 1280. Hello, hello. Yeah, I ran out of batteries. I was kind of wondering when that was gonna happen. Okay. So yeah, what I was saying is the maximum volume we support is slightly under 6 dB. So I picked 5. basically. And for the minimum, we support it's on minus 80 dB, although it's not really meaningful because you're not gonna hear anything at that point. But and so minus 80 dB is this, which is okay, B0. So these are the min-max values. We can implement the get cur, which is gonna be pretty much the same thing, except we're gonna use I mean, I should be able to just, like if I do int 16t star expert data, five times 256 minus 80 times 256. Well, all the code is already endian dependent. Like the entire USB descriptors are endian dependent. So yeah, I'm not trying to be. I mean, I could add like LE16 macro everywhere, but no, I don't. I have one micro. I have one macro at one, but that's it. Yeah. Like yeah, it's not ideal, but on embedded, I mostly don't care about being endian correct. Uh, what I wish is that there would be a way for the compiler to specify, like instead of int16 to say LE16, and that the compiler would handle that for me. But because one thing the compiler does handle for me is the fact that because I've defined it as a int16 pointer, but I don't specify that it's aligned, it will actually do 2-byte access. Yeah, no, definitely. But on the other hand, all this code is pretty much specific to my USB stack, which really only runs on RISC-V. So, I mean, you can run. I mean, I'm planning on running it on the EOS S3, but that's an ARM, which is also um, that ARM is at least a little endian. Is there a big endian ARM? Yeah, I think so. There is some weird ones, right? Yeah. Okay, so that's what I wanted to do here. And here I'm gonna say g audio dot chan -1 dot volume log. So what did I screw up? What? Yeah. Yeah, I haven't implemented that yet. That's the next step. And so here we also need to handle mute on channel 0 and then on channel 1 and 2. And if it's something else, that's not for us. Yeah, I think some MIPS are actually bootable in either mode, if I remember correctly. I don't know if there is that the equivalent for ARM. Huh, interesting. Okay, so okay, so something I'm gonna do is actually move all of this here. Wait, can I pre-declare it like that? I don't remember. Yeah. I'm just thinking, I'm gonna deal with that. Okay, so if gaudio.chan if we're already at the right volume, I don't want to change anything basically. And if we are not, then I'm gonna set the linear volume to volume log to lin vol log audio chan vol log vol lin to log. This way, when it reads it back, it get the actual value that has been set by the hardware and with whatever precision we have in hardware and not the value it's set. That's what the spec says you need to do. And I do this check here to ensure that, because this will not be equal to this. There's going to be some imperfection, and so if you call set volume in a loop, I want to avoid kind of progressive drifting due to the precision issue, basically. And then I want to call this, which is update the hardware and set the new volume. And when I set the mute, I want to do g audio dot mute all equal oh wait, I'm because at this point I don't have the values yet. This is called by the USB stack when it has received the setup packet, but it hasn't received the data yet. If we look in the example, you basically you need to do all your check and say that you are okay to receive the data, and then you provide a callback function, basically. That's what I need to do. Yeah, exactly. It's because, like, here the transfer is just one data packet, so it's not too much of a big deal. But you can have like very large control transfer, and if you need to refuse them, you need to do that at the beginning, basically. one thing I'm looking at here, I don't know if the transfer value, if I still have access to the USB control request at that point. I don't know how I can get a pointer to it. Oh, I can give it in the context. Okay, so I can pass it in the context, so that's good. I don't know if the callback just return a bool, because yeah, at that point there is really not much you can do except return true. I really don't see what you can do, because the transfer is over at that point, so you can't return an error anymore. However, something I think I need to check is I actually need to check the length according to the specification. I need to check that the length is correct for these. If rec w length divided as different of 1, it's an error. And here it must be 2 bytes. Okay. It's not callback. Callback done. Is there another callback? Oh yeah. You can have a callback when you're done and all the data has been received. Or you can also get a callback every time you get a chunk of data. If you're expecting, if you don't have all the buffer size to receive it all at once, sorry, you can get a different callback for all packets. So if you want to receive the transfer of 4096 bytes and pipe that, let's say, to the flash, you don't have to buffer the 4096 bytes. You can get a callback for every 64 bytes and pipe them that way. But here we don't care. We only interested when we have all the data, and we check here that we only receive 1 or 2 bytes, which we can buffer, right? I try to be consistent and do the -1 here. Okay. And here we need to call audio set volume chan and then expert data 0 or I mean I could do it with this, right? Okay, I think we should be okay. So we should handle all the control requests that we need to handle and adapt the volume accordingly. Let's try that. Okay. Warning, unlikely big volume range. Cval res is probably wrong. Uh, yeah, I think it's because like I declared that I have a very, very fine tuning of dB. Like I can tune by 0.001 dB, which is, you know, very unlikely, right? But it's not an issue. I wonder if it poses a problem if in a PA view control, if we look at this. Actually, let me move that here. Okay, so what's interesting is it lets me put it higher than the maximum I declared. Kind of wondering if this has any effect. Oh. Do you know if there is a way to tell it to do hardware only or? Fuck. Oops. So as a mixer doesn't like something. Cannot load mixer control invalid arguments. Of course, there is no debug or something. Oh, yeah. Let's see if we can. Okay, so apparently it's not a unique problem. Oh, yeah, but which card? Is there a way to list the cards? Okay, so it's card number 4, I'm gonna assume. Okay, sorry, I was surprised because my UPS started making sound, but I think it's just a periodic test. So never mind. So yeah, I mean there are volumes, so we can try cget. Four. Wrong control identifier 4. Num ID equal 4. Oh yeah, nice. So min max. So access value. Okay, so now I can set it to. So control set. We can set to 0. It should be 0 dB. UFP. Oh yeah, this is Monday, so I guess you can receive PCB. Nice. Are those for your keyboard or some other project? Ah, the SPI programmer. Yeah, yeah. Yeah, I guess the keyboard you were still working on it a couple of days ago. Ah, so what you already found issues before you got the PCBs? Yeah, that always sucks. So, how can you? Not sure if it's setting anything. I'm gonna add like a printf in the set volume. Yeah, but hopefully you will have received the other batch by then, and so you can show. I mean, it's always interesting to analyze errors and how they happen, but it's also nice when you have the solution already, right? Okay, so it did flash. Let's see if I do a control set. It's not calling the set volume method, as far as I can tell, at least. So either it's not calling it. Yeah, it's just not calling. I mean, obviously the get min and max work fine, which means that the set should be called if it's well called. Yeah, so that's all the get. Oh, it does call something. 0121. Right, so what is 0121? So 0121 is set cure interface. So it should end up here. I mean, in the set interface, of course. So this fails. Why? Oh, you know what? Something I haven't done, so I think that's not needed. Uh, yeah, I was wondering if I was initializing the transfer length to the request length by default, but yeah, the stack does that for me, so I don't have to do it manually. Yeah, sorry for the pause there. Will this also work on the old icebreaker? Yes, it will. Definitely. I actually added um, the PCF for the icebreaker on the repo that I pushed this afternoon. So the only thing you need to do is, I mean, you'll need a second USB connection, right? You need to connect the some pin of the icebreaker to a USB port. Give me a second. I'm just gonna go grab my icebreaker. So that's the icebreaker that I use sometimes for development for the USB stack. And there's the USB port that connects to the FTDI, and then I have a second USB port that's connected to some pins on the FPGA. You'll have to do that if you want to run this code, obviously, because I can't go through the FPGA. I can't go through the FTDI. No, I mean the bitsy that I'm running this on doesn't have a FTDI. Okay, so what did I screw up here? Yeah, exactly. So 02022. Okay. That was a dumb mistake. Nobody saw anything, right? No, the bitsy doesn't have FTDI. It uses a USB DFU bootloader. Yeah, it happens, but I thought I had a I have warning all enabled, and that should have warned me of a fall through if I mean I thought it would. Okay, so now I have volume set and volume set. And you can see the values here, they changed. It says 3000, 3000, and no longer what it was before. Okay. Oh yeah, I need to try to add those. Yeah, the version of GCC I have for RISC-V, I have no idea. So, I mean, I can try. Wait, I can actually try that. Let me, because I'm curious. Because that's. Let me recommend. If I do make here, I don't get a warning. If I do make now, oh wait, shit, I get a tons of warning. Oh yeah, no. Okay, I want no unused parameter because that's really annoying. Uh, okay, interesting. I can actually fix those quickly. Interface might be used uninitialized. That's interesting. That sort of looks like a merge error, to be honest, because that doesn't look right at all. Okay, what is it trying to do? Am I using interface after that? Yes. I'm pretty sure that's what it should be. Yeah. I mean, I would never have found that. I'm gonna need to push a fix for that in the submodule later on. But yeah, that's just interesting. And so yeah, no, I get the fall through error. Okay, I'm gonna check that it still works because, well, I changed something in the USB stack code maybe. uh, okay, that's actually weird. Volume set 0 to. So if I set 2170, that's gonna be the maximum volume. Yeah. Okay. So that works. Okay. So this. Yeah, I think so. I think so too. It's probably trying to discover like the audio value or something like that. It might actually be related to this or something. But it um, but yeah, it seems to set the value correctly. So the demo we did yesterday, that is pushing like the audio square wave, is still running, right? Because it's still in the code. I haven't removed it, so it's doing that. But now we have code that set the volume, so we should be able to plug and hear the volume change as we plug it in. So I did manage to pipe the line in from my audio card to OBS. So I'm gonna set the volume relatively low. And I'm gonna enable that audio channel in OBS. So yeah, I have no idea if how the volume is gonna be for you. So if you have headphones, beware. So do you hear like a very annoying sound? Yeah, if you remember the code that we did yesterday at a different volume for left and right. I confirm, yeah. Okay, so I'm gonna try to change the volume using a mixer, and that should change the actual audio volume. So if I just put 4000, did that change the volume at all? No difference, okay. I mean, I can try to lower the volume in OBS so that it's less annoying, slightly. Okay, I muted it. The time for us to debug. So it did call the function volume set, right? So oh yeah, but I'm an idiot. If you remember the code that we set yesterday, I override the volume at every iteration. Yeah, I changed it on my I changed it in OBS so that it was less annoying. Uh, but yeah, I need to remove this because obviously I'm overriding the volume every time, right? So I'm gonna set it slightly lower. So I'm gonna re-enable it in OBS. So according to the view meter, you can't hear anything at the moment. Let's try to bump that a little. Still can't really see anything in the OBS view meter. Huh. So that doesn't seem to do much. Okay, so the volume setting doesn't seem to be working now. Why would that be? Oh, you know what? We have the mute set. I need to find how to control the mute as well because I initialized them to 1, so I need a way to unset them. But I don't know. Is that this thing? Hmm. You know what? I'm just gonna disable the mute at the moment because it's more a problem with me and controlling audio mixer than really the interface. So I'm just gonna modify the code and ignore the mute flags for now. Okay, so okay, that seems to control the volume. Yeah, as far as I can tell from the view meter, that works. Okay, so I just muted it because it must be a very annoying sound. So okay, so we have volume control. We just don't know how to control the mute yet. That's something I'll need to look into. But that's more an ALSA problem than a really problem here. So as long as you control the volume, that's fine. So now we can try to finally move on to try to move data back and forth. So basically, we need to change this function to actually move data from A to B. Huh, yeah. For me, at the moment, I don't have any way to pipe data yet from the PC. So oh, damn it, I've been streaming for 2 hours and a half already. So the way the USB core works, sorry, you set up a couple of buffers, and I mean, you need to configure the endpoint basically. If you look in the documentation, you have a couple of registers per endpoint. Here you have endpoint status, and you have the configuration of the endpoint that tells the mode it's operating in. Here for the data buffer, we're going to use double buffering and an isochronous endpoint. And then you configure buffers to feed to the host when you have data, basically. Or not when you have data, when you want data, because we're receiving data from the host. So we need to fill the buffer descriptor, and then we set the current state to this, valid, ready for transmit or receive. And then when the host has fed us some data, we will get a status that tells us, okay, the buffer descriptor has been used, and we can read some data of it. So we can actually look at some code example that does that. Because I have a project that already has something similar to this. Osmo small hardware. Nope, that's not this one. And so I can reuse part. I mean, not reuse, but kind of know what some of the code to do. Okay, so there was a fix me somewhere. Wait, I'm not in the right file. Sorry, I got mixed up between my different windows here for a second. So that was all the control request stuff. Yeah, I'm just not sure where I'm gonna put the stuff to avoid pre-declaration and stuff like that. Okay, I'm just gonna put it here and pre-declare as needed. Data. Just sorry, I'm not talking. I'm just trying to think how I'm gonna organize this. So basically, when the interface is set, so there was, I put a fix me somewhere. Yeah, here. Not you. Sorry, no. If we're already in that state, we don't care. We don't do anything. If we have a change and we're not active, we need to start, and if not, we need to stop. So to stop the flow, basically, we're just gonna reset all the endpoints. Probably need to import a couple of headers to have access to all the USB stack internals. That's the stuff which currently doesn't have an API, like a clean API exposed, is configuring the endpoint. I need to manually manipulate the registers and look at the USB core documentation. So we need something like this. A P1 out. Does that well, yeah. So we basically declare that the endpoint one, which is the endpoint that we described. So if we look at the our descriptors, endpoint one out is the one we have for data, and we have a maximum packet size of 288, which means we need to set up a couple of buffers of 288 bytes. So pointer is where in the USB buffer the data is going to be stored. There is a 2K buffer because 2K is overkill because I can only have two buffers in flight. So I can put them anywhere in the memory. It doesn't really matter much. Ideally, I should have like some memory allocator so that I can dynamically allocate this, but that's not handled yet. So at this point, after doing that, the USB core will receive packets, well, at least two packets on the USB audio from the host. Except I put that in the stop function. That's obviously in the start function. And then I have the feedback endpoint, which is endpoint 1 in. And that I need to configure as well. It's isochronous, but it's going to be single buffered. Because we send data from time to time. And it doesn't matter too much. So that's what we're going to do. Single buffered isochronous. We're also going to pre-configure it as, yeah, the USB transmit and receive buffer are separate, which means that the address 1024 here is different from this because one is a transmit buffer, the other is a receive buffer. So I'm gonna prime this with some data. So this is the synchronization in which I must send a number of samples that I consume. Not no, not for the. I needed to specify it in the descriptors in the usage type. But as far as the USB core in the FPGA is concerned, feedback endpoint is an endpoint like any other endpoint. So if I look where I fill that up, okay, so I'm not entirely sure which value I must write in there. I know it's a function of the number of samples that I consume in a frame, but I don't remember if it's in byte or what unit it is in. Let me try to reread the USB specification about that. Okay, so that's this section. An asynchronous thing must provide explicit feedback by indicating accurately what its desired data rate is relative to USB frame. Okay. Oh my god. I forgot how fucking annoying that was. What do I fill it in with? I'm just trying to, because I know I worked it out for the E1 example, and I'm trying to see if I can derive the value for here as well. But I know that depends on, yeah, here I have a B interval of 3. And a B interval of 3 means that I'm gonna be sending data every 8 frames. It's two. It's an exponent. Here in the descriptor for this, I have an interval of 1. So I'm sending 1 every. Wait, no. Okay, I need to reread what B interval is, because what does B interval mean already? Interval polling for data transfer. Okay, so it is an exponent, but it's -1. So b interval of 1 means every frame, b interval of 3 means every 4 frames. And so here, every 4 frames, I set 8,992. $2,048. So, oh man, this thing is annoyingly complicated. I should have read that section before because I mean, is there a formula? Oh, k equals 10. Okay. Yeah, but that's actually not true for me, but okay. Measurement time can be decreased by measuring FM instead of. Yeah, that's not true for me. It's not a power of 2. Okay, this math is gonna be very annoying. Does anybody understand this thing? Okay, I'm just gonna fill with a random value for now, and we need. That's probably gonna make it buggy. I'm not gonna send anything, and we'll see how that works. Because oh man, the math to compute that. I thought it was easier than this, and that I just needed to send the number of sample that I consumed. But it's more complicated than that. It's like a fractional. Uh, yeah, I need to rework that, but I need to. I don't think I'll manage to do that on stream. I need to work that out and add it. But I want to just try to pipe data without synchronization. We can patch the descriptor and say that we're synchronous, and then we'll have some FIFO overflow on the flow. It's not too much of an issue. I mean, we're gonna hear some artifacts. And no, we. Okay. So now, basically, the only thing we have to do is check if we have enough. We need to copy data from the USB buffers to the audio of FIFO every time we receive a data packet if we have some space in the FIFO, basically. So a USB packet is maximum 288 bytes, which means it contains a maximum 72 samples, which mean check. Okay, so it's gonna be a no, we're just gonna get called continuously. Okay, check if enough space in FIFO. If so, the FIFO is 512. We want to be able to push an entire max size packet in it in one go. Else we just wait until we reach that. So if we have less than 440 samples in the FIFO, or sorry, if we have more than that in the FIFO, don't do anything at the moment. Check if we have a USB packet received. So one thing, because we have a double buffer, we need to keep track of which buffer we need to consume next. So I need to keep a pointer of the next USB buffer, basically. If audio.bdi equals 0. Okay, how do we know that? Well, we can check the endpoint status. So we can find some example code here. Something like that. So if we look in the USB core documentation, which I closed, I should have kept that open. Register documentation. Each buffer descriptor has a status, and we need, if we still this, which is the constant USB BD state ready data, that means the buffer hasn't been used yet, so we can't do anything. We need to wait for the core to receive a packet, basically. Now, we can either have received the packet successfully or we can have received an error, so we need to check that. And if it's an error, we can't do anything with the data. We have to just prepare it for the next, but we can't read anything from it. Yeah, that's it. Actually, I'm just gonna do it like that. um, okay, something I forgot. When we start streaming, we also need to stop playing audio. If we have enough in the FIFO, enable core. If audio level, let's say if we have more than 200 samples, we can start playing. Okay, so the general idea is we get the current status of the next buffer descriptor. We check if it's not ready, if it's done, and if it's done with valid data, we take that data and copy it to the audio FIFO, and we prepare for the next transfer, which is basically just refilling the just resetting this. And we need, so here we need to copy data from the USB buffer to the FIFO, 32-bit at a time, depending on the length of the transfer. So the length of the transfer you can get in the buffer descriptor status, you have the state, but you also have the length, which at the beginning you set to the maximum length, but the USB core the disconnect, it's the remarkable. My tablet has gone to sleep, and so it disconnected because I haven't used it in like 1 hour or something. And by default, it appears as an Ethernet device, and that's how I'm streaming its screen to OBS. So the buffer length. How do I get the length here already? Okay, that's the length. That's the length of the packet that has been received, and I need to copy that many words into the FIFO for 4. I'm copying 1 word at a time. Okay, so there is a helper function to copy a buffer information from a USB buffer to the main memory, but I don't have one written to copy to an IO memory mapped address. So I need to kind of do this manually here. Okay, so except for the USB feedback endpoint, that should actually be good. So I mean, the data transfer was really not that bad. Like it's really just that, which is not too much, copying data from the USB buffer to the USB to the audio FIFO. Let's load that. So the question is now is how do I test that? Yeah. So I need something. Okay. I need something where I can specify the audio output manually. Is there a play for MP3? So first, I don't actually have any file to play. Socks can generate tone, yeah, but tone are annoying. Let me copy at least an audio file from my laptop to the. Maybe because the card has been plugged, it will be taken as the default card, and I can just play something. Oh yeah, Twitch doesn't have a copyright. I don't think. I'm on. Okay, that's still. What are you hearing now? Wait. The thing is, like, I can't actually hear what you're playing, so I have no idea if that's gonna work or not. Okay. Okay, so I actually playing my own stream so that I can see if I hear anything. I need a earbud. So I'm gonna re-enable the audio. Okay, so that's nothing, probably because the volume is rather low. Okay, let's just.
One more drink, one more Bacardi, one more dance at this after party. We still going strong. Speed so fast, like a Ferrari. We get wild, like
So something's obviously wrong.
we still going strong.
Yeah, I mean, that's probably related to the fact that I declare myself being a asynchronous endpoint with an explicit feedback, and I don't provide any feedback whatsoever. How could we somehow inspect? Okay, so the first thing I want to check is make sure that I only receive packets that are of the right size. So what if I actually do just. I'm gonna keep it muted because it's a horrible noise, but we'll see. We'll be able to see the output. So we actually get a bunch of 194 byte packets. Does it change anything when I play something? No, it doesn't. So 194 bytes is actually 48 samples, which is sort of what I'm expecting. Okay, so I think we're filling up the FIFO. It's kind of stuck at 485. Something I can check is actually how many frames have elapsed. Um, you can ask the USB core for the current frame number, USB frame number, I mean. In theory, there should be one frame between each of them, right? Of course, how the hell am I gonna read that fast? Yeah, I can't. Like, there's no way I can. I'm gonna print the difference between the last one. So we see that we are slightly overflowing the FIFO from time to time, but not that often actually. So I wouldn't expect it to be that bad. So we're definitely not consuming data fast enough. because we're filling the FIFO rather quickly. Yeah, so what's happening between buffers is that since the FIFO is full, this check will not match basically, and so I'm gonna wait. Yeah, I won't. Basically, yeah. Well, it's yeah, but the thing is, isochronous doesn't have the concept. Like the host has no idea that I even read the buffer, right? Because if I don't submit a buffer to feed data, what's gonna happen is that the USB core will see, okay, the host is sending me an isochronous transfer. I have no way to signal to the host that I can't receive that data, so I'm just gonna drop the data. That's basically what the core does because it has no choice. So what's missing is basically the synchronization where I tell the host that I need less data. That's kind of the missing piece here, I think. Honestly, I would have expected it to be better synchronized than that. Um, something we can quickly try is just hack the hardware and make it consume samples faster. So let me edit. So we have our tick generator 498. Let's say we say 490. I mean, we could look at the traffic. So I can try Wireshark to see if a USB mon would work. I also have an open Visla, so I have actually a USB analyzer that we can plug and just dump the raw traffic. But I kind of have a logistic problem with that. Is I don't have any USB port free on my PC at the moment. Every single one of them is used. Uh, so the rate matching is much better now. We can actually try to see if the audio sounds better or not. Let me enable that. So I'm gonna set the volume, enable OBS. Yeah, but there's still that noise floor that I have no idea where it comes from. Yeah, what is that from? Oh, does the right channel is completely garbage, or is it half good and half bad? Yeah, there is audio. I don't think the left is perfect. I think there is something in the left as well. Um, so let me see if I can get Wireshark running. Yeah, the left was silent when not playing. Oh, sorry, I forgot to disable it. Uh, hmm, something I'm wondering is if I need, because all the access must be 32 bits, and so I might need to declare that this is aligned. Is that correct? No, that didn't change anything. Yeah, I have no idea what the C11 alignment macro is. Oh, wait, ATM. I'm looking at your. Oh, okay. Interesting. It's a bunch of spikes. Yeah, it's really surprising that one channel does one thing and one channel and the other does something else because th- yeah, but the thing is like both channels are identical in the hardware. You know what? Let me actually. So what I'm gonna do is I'm gonna take the value and manually replicate it to both channel. So I'm keeping the lower 16 bits, and then I'm replicating in the higher bits. Oh, okay. I didn't know that syntax. Yeah, that's definitely more. I mean, that's less underscores and less parentheses and less things to go wrong. It's still doing it. Oh, wait, no. When I set the volume for both channel, then both channel have the issues. Wait, what if I take the other half of the samples? Wait. Okay, so now they're both quiet. And if I play something, there's definitely noise, something wrong, but it's less wrong. Yeah, but I'm asking for 16-bit samples. I'm not asking for 32-bit sample. I want the host to send me what I want. So let's see if I mean, the thing is, the host is sending me 194 byte packets. Does the volume multiplication overflow or something? Uh, I mean, it shouldn't. So when I set the volume, we can actually see. Oh shit, that's not what I wanted to do. Set 0 to 520. Minus 3400. I mean, you know what? We can just disable volume control to make sure, like, we can modify the hardware and temporarily disable volume. When I have left and right packed into the same channel. Yeah, but if it was trying to send me float 32 or in 32 samples, the packet I would receive would be bigger. Oh, you think it's interleaving them or something? Wait, like one packet from left and one packet from right? I mean, they're supposed to be interleaved, but not. Well, yeah, in the same packet, that's what I want. I want one sample from left and one sample from right. That's what I expect. And I push those 32 bits at once. So here, volume is completely bypassed. So there's no multipliers or anything. Surprisingly, there is no noise. I mean, not sure, not surprisingly or what, but uh, let's play something. Yeah, okay, there's no noise, but there's also no audio. Did I screw up somewhere? Oh, yeah, of course. Yeah, I can try to play a left-right tone. I'll do that as soon as the build is done here. I can already load the video. Well, probably I have to kind of copy the ID. Uh,
Welcome to panel 2 of the IEEE International Smart Cities Conference. I'm going to turn it over to Andy Chen, who is the moderator for this session.
Good morning, good afternoon, good evening, wherever you are.
yeah, I still have the conjoint channel thing, so I need to disable that in the firmware. I still have noise on one channel and not the other. No problem, no problem. Huh. Yeah, so one of the channels is definitely not good. Uh, Yeah, I mean, I'm not 100% sure of what the audio quality outputs of the. Sorry, it's weird. I had still on my headphones on, and hearing myself with a 2-second delay is like absolutely horrible. So yeah, one of the channels is currently I'm more concerned about the why the channels are not the same. That one channel is bad, that the other are small glitches. Well, first, we know we still have synchronization issues, right? Which is going to cause skips and stuff like that. And the other is there is some analog element in the past, like I'm feeding a PDM output directly to the line-in of my sound card. I have no idea of the quality of that, and that might cause some glitches and some high frequency noise and stuff like that by itself, right? So at the moment, I'm more concerned of why is one channel horrible, basically. Yeah, there is some filtering, but when I looked at it, I tested that on the icebreaker, just generating static waveform and looking at it on the scope, and the filtering wasn't filtering absolutely everything. You still had some high frequency leaking through that filtering. And so I'm kind of wondering why. Why the samples are that way. So let's see if I can get Wireshark. I mean, you can check the USB descriptors for the format, right? Audio streaming interface descriptor. We can reconfirm the specification for that. So let me format specification. The number of physical channel in the audio stream. The number of physical channel on the audio stream. So that's 2. Makes sense to me, at least. What the PDM? What do you mean that the PDM is free running? Like the PDM runs all the time, but the value at the input is changed only. Is changed at the sample rate, basically. B subframe size is 2. The number of bytes occupied by one audio subframe. And we ask for the PCM format, right? Format type 1. Yeah, format tag PCM. Yeah, that's correct, Conrad. Yeah, sorry, I'm reading the specification. Sorry, I'm sorry. I realized that I even talked, but I'm just trying to find something wrong in the descriptor or something that would send weird data on the USB, but I don't find anything. So no. Rochelle, you said there was a way to update the groups without relogging in? I don't. What does new group do? I've never used that thing. Otherwise, after. Yeah, I have added myself. I'm there. I've never used new group. I have no idea what the fuck that thing does. Just to change the current group ID during a login session. Yeah. Unfortunately, that doesn't seem to work. Well, no, that's the thing. I haven't, because if I start a new session, that's gonna kill OBS on on the stream. Okay, Conrad, bye. Honestly, I think I'm gonna stop, and we'll need to debug this another time, because it's getting late. and I need to go to sleep too. So I'll push what I have, and we'll see. I was hoping to get it debugged and completed today, but I'll reread the synchronization part of the USB specification and try to understand it, so we can fix that at some point, basically. Thank you everyone for joining, and you know, if you have any idea or want to discuss, or if you have an icebreaker, you can also try it. On your icebreaker, you just need a USB cable to connect it, or if you have a bitsy already. So yeah, see you guys later, and again, thank you for joining. Bye.